Welcome everybody. This is Chris Bramlage. I'm with C&E Sales. I head up sales and marketing here, and this morning's webinar is covering the MiR Mobile Industrial Robot product. Specifically, we're going to get into looking at some of the new features and the new layout and the 2.0 interface. MiR, kind of like a smartphone, is constantly evolving its software algorithms as well as its graphical user interface. And this 2.0 was a significant jump from the 1.0 in layout, ease of use, and capability. And that's really where we're going to focus the majority of our time today. Quick housekeeping note, if you have questions in your control panel pane, there is a questions spot. We'll stop about every 15 minutes and just verify that there's no questions there. I'll pop that open and take a look. Don't want to get too far ahead if you've got a question that needs to be addressed. Well, I'm going to just jump into it. I've got a couple of slides that I'd like to show just to settle in with everybody the idea of an autonomous mobile robot versus a guided vehicle so that we're all on the same page. And then I'll talk a little bit about what's under the hood of the robot, a couple other slides. And then I'm going to open up the user interface. I have a connection to a robot here in our office. So one of the features of the mobile industrial robots is the ability to have two Wi-Fi channels on board. One Wi-Fi channel can be addressed right from your smartphone or tablet when you're nearby the unit, and you can drive it around, you can command it from there. The second way in a factory environment is that second Wi-Fi channel would be connected to the LAN for the plant. And that's kind of what I've done here at C&E. I've got this particular robot attached to our local LAN. I'm on that LAN as well. And so instead of calling it up like I do on a cell phone with mir.com through a browser, and where I get those web pages served up to my cell phone or my tablet, instead I call it up by IP address. And the IP address is readily found inside the user GUI under the Wi-Fi settings area after you've made the connection to that network. So AGVs is a robot that generally follows a predetermined location route within a plant, and oftentimes that is guided by either wires or magnetic tape or some remote lasers and some prisms. And so the drawback with those sorts of applications or applied products is that if you need to have the route changed, there is some work that needs to be done to the factory itself. If there's something, an obstruction that gets in the way of the robot is paused there until that obstruction is removed. The autonomous mobile robots act quite a bit differently. I like to describe them when you first get them as a TomTom without a map. And once you place a map into the unit by simply walking it around the plant floor and it constructs its own map, then it can act autonomously. So if there is a hazard or an obstruction or a fork truck or a person or a pallet in the way, it simply modifies its route so that it finds the best, quickest route to its final destination. And if an entire aisleway is blocked, that may mean it has to go completely down another aisle and around a different path and come back on its location that it was sent to. But it tends to always find a way to its final destination. In real simplistic format, here's what that looks like. The top, the AGV, is going from the left to the right, and it's following that guided path. Something gets in its way, it's going to wait until that object or fork truck or whatever it might be gets out of the way before it can continue. The autonomous mobile robot will identify, see those obstructions with its sensors, and navigate around them based on replanning that route. Quick look under the hood of the MiR 100 and 200. Up here in this upper left-hand corner, you've got some power supplies. There are various power requirements for the different devices on board the unit, so those power supplies handle that. You've just got some simple terminal block wiring here. This big block of yellow is a safety PLC. So the safety PLC is working in concert with this scanner and this scanner. Those scanners each feature a 270-degree viewing angle so that it has a full 360-degree view around the robot at all times. And if someone comes into its positional alarm point, it will stop the robot via these force-guided contacts here. So you've got force-guided contacts that are being monitored, the PLC, and those all act together in concert as a safety system. The blue object right here in the middle is a charger. You can hook to a charging dock, and the charging dock has some plates up front that make contact with this charger and then can charge the battery. Right now, this unit pictured has the single battery in place here underneath this yellow part. There is room for a second battery for longer use without charging. This device here is a combination of accelerometer and gyro and inclinometer. It's a special board manufactured for MiR, one of the few special items on board. The rest of this is pretty much off-the-shelf hardware. You've got a speaker system here that allows it to play sounds, beeps, foghorns, music, whatever MP3s you'd like to download to it. It comes with a couple of horns and beeps already loaded from the factory. This device here is a 3D Connects camera that helps it visualize objects that are not at the 20-centimeter positional plane off of the floor. That's the plane that the laser scanners operate at. So it's seeing ankles and stanchions for machines and whatever is at that height. But as it's moving forward, it's got the 3D camera to help look for other obstructions. Down underneath this cross member here is a NUC, an embedded Intel NUC computer, and that's where all the magic happens. That NUC also has, like I said earlier, a wireless channel that you can connect to and enter the interface directly from there and navigate from there. You've got some contactors in this area, and then some connections to both power the computer and down to the computer via USB in that area. Up here, there's also that second wireless device. This is the one that would connect to the local LAN, and through the local LAN, then that robot could be reached anywhere in the facility. Not going to spend a lot of time on these. If you'd like, you can email me. In fact, why don't I do this? When I finish this, everybody's attended or registered, I'll go ahead and send this slide deck in a PDF format. I'll also send a PDF of the brochures for both the MiR 100 and 200. So you can see the MiR 100, the payload is 100 kilograms, 220 pounds. That'd be vertically down on top of it. So this is a platform that you can use to attach whatever you'd like to it. It could be a shelf system. It could be a rack of a tool box on top of this that's locked. It could be anything on top of it. We'll talk about the hook and towing capabilities here in a minute. You see the max speed. Those max speeds are there because it falls into the collaborative robot standard, and that calls for a max speed of 1.5 meters per second, a little over 3.5 miles an hour or thereabouts. The range on a full charge, 10 hours or 20 kilometers. And you can see the weight for this device is about 138 pounds. That's before you add any other payload up onto the top of it. Battery charging, as it says here, you can go 0 to 80% in just 2 hours. Communication on board, I talked about the Wi-Fi. It also has Bluetooth, so that there's an optional Bluetooth module where you could control doors. If you've got a door in your plant where people use an RFID reader to open a door, this allows it to then use its Bluetooth signal onto a device attached to that door, small relay system that could open that door and let it continue on its route throughout the plant. Ethernet and PLC both on board. The PLC is an adder. You place a PLC on board, and through a serial interface you communicate registered data back and forth to the programming environment. Complies with all the safety regulations. That's so it meets that collaborative standard, and it is CE certified. And then if you double that payload, about all the other specs are very similar. You see the towing spec has been added to this MiR 200. It's a 500 kilogram tow that is using the hook I'll show you in a minute. The other unit, the MiR 100, has a tow capacity of 600 pounds. Gives you a little bit more detail on the safety system. And then this is the charging station that's available for it. You've got two spring-loaded pins down here that make contact with metal plates up on the front of the unit when it's docked, and it verifies continuity, and then it sets its charging relay and begins to charge. So it can do periodic charging so that it can run a lot longer than the 8 or 10 hour, 2 shifts in a row, simply by convenience charging when it's not got a task on its mission queue. This includes a VL marker for accurate docking. The little indenture that you see here, this V-shaped indenture, assists with the laser scanners in positioning the robot to within plus or minus a centimeter. Yeah, you heard me right, plus or minus a centimeter position-wise. And I verified this. I'm kind of from Missouri. I didn't believe that it could accurately locate itself. I put a couple of laser pointers on 2 of the corners of the robot and went and moved it back and forth 5 or 10 times, and it had a very strong repeatability using this VL marker system. Just kind of a picture of a VL marker. The VL markers can be bent up just out of plain metal, and they can be used on applications where you need to get this thing in a very accurate position versus the plus or minus 5, 10 centimeters that it normally has. You can set it to a really tight location. The sensors on board the robot, there are ultrasonic sensors. Those sensors are right here. They assist the robot if you're coming up perhaps on a glass wall. You've got glass doorways, so it doesn't run into those glass doorways. The lasers may or may not bounce back accurately off those glass doors, so there's some ultrasonics built into the front. The 3D camera we talked about when we had the lid off of it. These 2 apertures right here are where the 3D camera is looking through that cowl. Encoders on each driven wall. Gyro and inclinometer, accelerometer, all in that little yellow device I pointed out earlier, and those 2 laser scanners. So as this device is moving around, it's tracking its encoder pulses. It thinks it knows where it has gone to, and then it verifies that by feedback from the laser scanners relative to the map that it had already created when you walked it around the plant for the first time. This is the flow chart for implementing a MiR first time. You connect wirelessly, and seriously, you just grab your cell phone, just like you're looking for a wireless network at Starbucks. You open up the one that's for MiR. You do have a couple layers of password to get into that network, as well as to manipulate the software. But you connect, you create a map by walking it around the facility. You edit the map, and I'll talk about editing the map a little bit more later. You teach it some positions, and then you build a mission and have it run autonomously. Alternatively, instead of building a mission and running missions, you can just teach the positions and use it in what's called a taxi mode. So you can say, robot, I need you to go to column 42B, and you point to that spot on the map, and it asks you if that's what you want it to do. You affirm that, and it takes off, makes itself over to that location. I've got a couple of screenshots of the 2.0 interface, and I brought these up because I couldn't find an easy way to show you the interface on my cell phone during this webinar. So the picture off to the left is a screenshot from my cell phone. You can see that up at the top, the address for the unit, 192.168.3.145, off of the wireless network that it's attached to. And then what you'll see here is one of the dashboards that's available, and we'll talk about dashboards as we get into the software. And then you've got a joystick right here. That joystick is where you can take manual control of the unit. Say it's gotten itself totally stuck. People have boarded it in from both sides of fork trucks. After X number of retries, it'll send a text or an email at your discretion out to somebody to help it be rescued. Person may come over here, make a wireless connection to it, use a joystick to drive it out. The joystick is the method I use to drive it into people's facilities to do demonstrations. But you've got a series of icons up here across the top, and then this 3 dashes brings up a complete menu system, and I'll show you a picture of that in the next slide. Whereas off to the right is more of the laptop interface from about that same position. So I've got a dashboard brought up. It brings up more menu items off to the left that would be available through either through this 3 stripes here. But I could select the default dashboard, a dashboard that I've created for myself, and a couple of others that I've created. And you've got a full menu down the left-hand side for functionality, and then you've got some quick items that you can accomplish up across the top. You also have a current battery indicator. So here are 3 screenshots solely from a cell phone. So off to the left is I've brought up that main menu system with those 3 bars, and I've also touched on opening a joystick. So I've got a joystick opened at the top, and I literally just touch this joystick with my finger, move it forward. That causes the robot to move forward. If I move it hard left, it just spins in place to its left, right, and then backward. And then from here, I can open up those submenus. For instance, I clicked on dashboards here, and you see that it drops open a menu where I could get to those same dashboards that were off to the left in the laptop interface. They really took a lot of time. They brought in some good developers for both cell and web interfaces, and they really wrote this application well with good organization. I find it much more intuitive than their 1.0 interface. And then over here, it's brought up one of the maps, and I'm able to actually through the dashboard, and on this particular screen, I could touch on any of these points and tell it to immediately travel there, acting in the taxi mode. We've been in it about 15 minutes now. I'm just going to do a quick check to be sure there's no questions. Any questions, just pop them in. I don't see any yet. I'm going to pop back out then and get back at it. So here's another screen capture from the cell phone. Main menu. Now I'm under setup, and I could from here create missions. I could work on the maps. I could delete maps. I could edit the maps. I could select a different map. I could add some positions or markers like VL markers and charge stations to the map. I could control its sounds. Transitions. Transitions is the area where you create overlapping points in 2 maps so that as the robot travels, it can then make the transition to a different map. And let me describe why and how you might use that. If I've got a large factory and I have mapped it all out so that the MiR can make its way throughout that whole factory, you'll find on the user interface, especially when you get down to a small tablet or a cell phone, that that map is very difficult to look at and to find locations in it. So it may behoove you to break your factory up into several maps so that it makes it easier for the operators in given areas to understand where that robot is and be able to easily call missions up for that rather than having them all on one. And those transitions are points that are in 2 maps so that the robot can hit that position, pause briefly. It takes about 5 to 7 seconds, pause, changes itself over to the other map, and continues activity. Bluetooth relays, we talked about that a little bit, so I could open doors or activate other things with that Bluetooth module. And users and user groups we'll get into a little bit more. Here's where I clicked on maps, and now I'm down to whether I want to create a map, I want to bring a map in, etc. So you can see logical progressions throughout the software package. Again, kind of the same thing, all the menu up. Now it goes into dashboards. Here it goes into setups. Here it goes into monitoring, just showing you some of the submenus. Same thing showing system. So I clicked on system, opened up the different options under system. clicked on hook, opens up different options for the hook. Really well laid out. Let's talk a moment about the hook. Good picture here of the hook attached to a cart. I'm going to point out some key features on this hook. First of all, it mounts directly to the top of the robot through those 4 mount points that I pointed out earlier that I said you could attach a shelf or other things too. There's also some top lift systems that are available for this, but the hook is one of the most popular options. So this hook has 3 different actuators on it. It's got a linear actuator here that's powered by the 24 volts off of the robot, and that allows this whole hook assembly to go up and down. So when it's getting ready to pick up a particular cart, it will lower its hook down to the area that you've pre-programmed for it to allow it to glide underneath the cart. Then it will raise that back up to the point where it'll be able to clamp onto the cart itself. At that point, there's a second actuator right here in this area that forces this bar against the hook underneath to clamp onto that particular cart. And once it's got a cart in its grasp, there's another actuator system that's a ball screw right in this area here that allows 2 plates to separate, that is the locking mechanism, or brake as they call it, to hold the hook in place. So that if I don't have a cart behind this robot, that hook assembly is locked directly behind, as you see it in this upper right hand picture, so that as I turn around corners, that hook assembly doesn't slide out and hit a wall or somebody. So it's locked in place right here. But as I pick up a cart and clamp it appropriately, then I release that brake system and allow that cart to follow the robot as it's moving from point to point. You'll see that as it drops a cart, the last thing it does before it releases that cart is to square up with that hook assembly so that when it's moving without a cart, that it is locked directly behind it. Talk a moment about fleet control. Working on an application right now for a customer in the Cincinnati marketplace. That customer is moving work in process throughout the facility, and they're going to be using fleet control with a couple of the MiR robots with hooks. And at any given station, an operator will be able to select a particular mission, and it will be pushed to the robot that is the closest, or is the least busy, or has an adequate charge for the job. It does all the management behind that. The form factor of this fleet control is a piece of software and a piece of hardware. The piece of hardware is one of the Intel NUC PCs running the fleet software. It then is attached to a local router that services the LAN, and that way anybody who selects a mission talks up through the local LAN to the fleet control system. The fleet control system then drives those missions down to the robot level. A few of the references, people who are currently using the products. All right, I'm going to jump out of that and jump into the interface itself. So I've got the interface up right now, and I'm going to double check for questions at this point. Don't see any questions, so I'll keep moving. What you see here pictorially is a layout of the office area that I'm in. I'm currently inside of this office right here. This is a hallway. I've got my controller's office up here. His name is Bob, and by the way, you'll notice that we've named the robot after Bob up in the upper left-hand corner. It's because Bob always liked messing with the robot as I'm manipulating it around the hallways. What you find to begin with when you're introducing a mobile robot that's autonomous into a work environment is at first people stop and stare. They're afraid of it. They may want to challenge it. That's what Bob did quite a bit. That's why it's named after Bob. But pretty soon, a week or so into it, and they see that it's going to go around you and stop for you and go about its business without any interaction with humans, people begin to ignore it pretty quickly. So it's pretty easy for people to get used to it. I talked earlier about the taxi mode, so I'm just going to demonstrate the taxi mode real quick. The robot is currently right here in this position, and I'm just going to zoom in a little bit to show it a little more graphically. And you notice it looks like it has a little trapezoidal tail on it. That's because this particular robot does have a hook assembly on it right now. And so their perimeter for guarding this particular device and to allow for turns and other things is extended out to the back. And we call that the footprint. And the footprint is able to be manipulated, and you're able to set different points around the device to create a new footprint. And you do that when you're adding different loads to it. So as a part of the hook, when you're training carts for this hook assembly, you have to get into the software and tell the software how long, wide, and tall those things are so that it can accommodate those with turning radius, etc. Taxi mode, I'm just going to click on this point right here, and you can see this position is called near Crispy's office, and I've got some options here. I can send the robot there. I can move the position on the map, so I can relocate that position. I could edit it, change its name, type in new positional coordinates for it. I could delete this position or just cancel this spot that I've clicked on. But I'm going to tell it to go to that position, and you'll see it immediately created a route with the little dotted line, and it's moving its way down to from Bob's office down to my office. Now, I talked about as the robot moves, it's got encoder systems that constantly are looking at how far it's traveled and reassuring it knows where it's at. If you'll notice that along these walls, these are all walls, and you see this red outline. That red outline is the current data coming back from the laser scanners. You can see that there's no black wall right here in this area, and yet it's showing a red laser scanner. It's because my office door is closed. I tend to be rather verbose, and while I was doing this webinar, I figured it'd be prudent to close my door to allow the rest of the office to continue their work without interruption. I'm going to send the robot down to Diana's end of the hall. Diana is our HR manager. Now you notice down by Diana's area, there's this pink area here. That's an area I've added to the map called a forbidden zone. So there's a small hallway back here I didn't want the robot to go into, and so when I was editing the map, I cleaned up that area by just not allowing the robot to go back there. You also notice this purple cloud around walls. That is the data that's coming from the 3D camera. And so the red lines that you see are the laser scanner data, and then this purple data is the 3D camera system that's on the front of the robot. And in fact, with the hook in place, you actually have a second 3D camera system that's pointed at more of an upward angle, and that allows you to look for obstructions that might run into either the hook or the carts that the hook is pulling. So in the hook manual, you'll notice that there's a maximum height for a cart of 2 meters, and the extension of that 3D camera goes up to 2 meters in front of the robot, just to make sure you don't go under any low-hanging items that could be hit by the cart itself behind it. All right, that's the basics of that portion of it. I think we'll get into some of the menu items now. We're currently at about the 11 o'clock position, so I'll take one more look at the questions. And seeing none, I'm going to continue. All right, first let's go into the dashboards. I've clicked on that, and you can see by the little triangular indicator there, so I'm in the dashboard menu. There's a default dashboard. This is my dashboard, and my dashboard I created has 3 different components. This component here is a map, and we'll show you how to build a dashboard here in a minute. And as I scroll down a little further, you see that this area contains a mission queue, which are missions or tasks that the robot's been asked to do and the order in which it was told to do them. And then down here near the bottom, I've got all of the missions that have already been created so that I could click on those and send them directly into the mission queue for the robot to act on. So I've got this little mission here called Milk Run in Management Area, and I'm going to click on it. When I click on it, it'll be added to the mission queue. You see right here, the mission queue contains Milk Run in Management Area. And the first task that it's doing is moving to Bob's office. So if I go back up to the map, you'll see that it's going up to hit the point near Bob's office. So it'll spin around so its orientation is forward, just like the marker or the position that was set for it. And then you'll see this area update for showing its next move. Now it's going to move to Diana's end of the hall, and it's on its way to the next step. Once it completes that, the perimeter lighting, the LED lighting on the perimeter of the robot, will change from the blue, which is during a mission, to green, indicating that it's ready for a new mission. So let's just go into dashboards for a second. So I'm going to click on the dashboards icon all the way down at the bottom of the menu, and it brings up this interface, and I'm just going to create a dashboard. I'm going to give it a new name. I'll call it Webinar, and create the dashboard. And then I can add different items to the dashboard. For this one, I'm going to add a 2-column row, and then I'm going to add a 1-column row. Up here, I click on the 1-column, first column, and you see my options. I think on this one, I'm going to put a joystick off to the left, and I'm going to maintain a very slow speed with that joystick where someone can jog it out of a position if they need to. And over here on this one, I'm going to do a robot summary. That will give me things like current charge and status. And on this one, I'm going to throw in a map area. And I'm going to save that. And it by default then brings up the webinar. And you see I've created a dashboard that's got a joystick. It's got a status. So the robot's name is Bob. And it's got a 73% charge. Here's the battery time and the uptime and how far it's moved. And if I go down and look at the map, I can kind of position them both together. The robot's currently facing this direction. So I could go into manual control and I could move that robot forward manually using the joystick, and it would only advance at the slow speed. So there's how hard dashboards are to create. Think about it in these terms, especially once now we're going to jump into the users. So I could create user groups for different parts of the plant and create custom dashboards for those user groups that only give them access to some missions that are pertinent for their area of the plant. So real clean and quick, easy way of creating a custom HMI, GUI, whatever you want to call it, for those operators to work from. I'm going to go down to Setup now, and I'm going to go to Missions, and we're going to create a mission together just to show you the easy programming environment. First off, the one that I just did with the milk run, go down here and look for it in alphabetical order. So there's the milk run in the management area. I've got 3 icons here. I could edit the mission, I can delete the mission, or I can queue the mission. If I queue the mission by clicking on this icon here, it's going to automatically start the robot through the same process that we saw before, going up toward Bob's office, back to Diana's office, stopping, ready for its next activity. If I click Edit, it will bring up the 2 moves that are a part of that mission. And if I want to rearrange those moves, I simply use this little icon off to the left to resort them in terms of their timing. And if I want to further define what I want to do in any given move. So this is just a move command. So the options available to me are the different positions that are in the maps for the current site that I've created. I could validate and close. I could remove the action. I'm just going to validate and close. If I were to try and jump out of this area without saving by saying go back, it does remind you, hey, do you really want to leave this mission, this particular mission edit, or do you want to stay? Since I really didn't change anything and I arranged things back the way they were, I'm just going to jump out. So let's create a mission, and I'll call it webinar. And you see, I can put them in different mission groups. Where that becomes important is if I'm going to do those custom interfaces for different people in different areas of the plant, I probably want to group them, because when I select missions for a part of the dashboard, I can grab a particular mission group and only expose them to the missions that are pertinent for them in that area. Also, there's this site, and the site means what group of maps. Right now in this particular site, I have 2 maps so that I can show you the transition from one map to another as well. And those are both under CE, and you can create sites as well as maps. So I'm going to create that mission. And you see up at the top, I've got a range of things that I can go into to add to that mission. You also notice that there's a little arrow over here to the right, and if I click on that, I see some additional ones. I can queue missions inside of a mission, so I can do sub routines, if you will, or create loops. And then under the cart, that's the activities for the hook. Go pick up a cart, go place a cart. Going to go back to the beginning, and I'm just going to do a couple of simple things. I'm going to throw a couple of moves in there. You can see I can move to a coordinate. I can do a relative move. I can set the footprint, and we talked about that a little bit. Let's say that I know in some particular point in the mission, I pick up an object that's larger than the overall shape of the robot itself. I can add a set footprint command and let the robot know that there's a larger object on top of it, and it's got to make allowances for that as it moves around the map system. And down here, the switch map, going from one map to another. But I'm just going to add a couple of moves in there, and I'm going to add play a sound, and I'll show a light, and logic. I think I'll also put in a wait command. And so I've got 5 different pieces to this mission, and I'm just going to modify them, rearrange them, and create a cohesive mission. So I'm going to first move to the position at the one end of the hall, Diana's end of the hall. At that point, I think I will have it play a sound. So I'm going to move this sound up next. And what are my options under there? I think I am just going to beep. It is an office environment, so I'm going to lower the volume down quite a bit. And I'm not going to mess with the duration. I'm going to have it full length, which will be a series of beeps. I'm going to validate and close. I'm then going to move to another position, and we'll move to the other far end of the hall, which I call Bob's office. And at that point in time, let's do something with lighting. And we can open that up, and let's do a rainbow fast. So it'll spin rainbow colors around the outside perimeter. And I'm going to validate and close. And it's going to sit there and wait for some period of time. 1 minute. So there's a full mission. I go back up to the top, I can save it. And I can go over to dashboards, bring up my dashboard. I got the webinar mission, click on it. You can see that This milk run and management I'm going to delete. And now the webinar is the one that's left. You see up at the top, the robot had been paused because I got into the programming environment. And I'll go ahead and start it, and it's starting the mission by moving to Diana's end of the hall. So there it is, moving to Diana's end of the hall. Just had to back up a little. I can hear it beeping right now out in the hall as it passes my doorway. Luckily, I selected 10% volume. It finished that beep wave file or MP3 file. It's on its way up to Bob's office where it'll start the light flashing and pause for that minute. So there's a little bit of the mission interface. We are at 10 minutes past. I'll take another quick look at the questions. Is the joystick speed just top speed or also safety acceleration? 2, levels of user access, limited dashboards for associates versus programmers. We're going to cover the second question, the levels of user access, here in just a minute. Is the joystick just top speed or also safety acceleration? Let me just describe how the joystick works. So if you set it to fast speed, as you move it, it reacts pretty quickly to your commands. If you set it to a slow speed, it reacts pretty slowly. At any time when you're using it, the safety systems are still in place on the robot so that if it comes near an obstruction, it's going to go into an e-stop. That's a recoverable e-stop. It's not one where you have to interact with the robot to get it moving again. You can simply remove the obstruction or move the robot and it'll let itself run again. Thanks for the questions. And we'll get into users because that's a real key issue of this whole dashboard. So I'm going to go into setup and I'm going to go into the user. Well, let's go into user groups first. So here's some user groups. Let's just take a look at them. Let's look at users down here right now. So you can look at the permissions and you can edit this or you can delete it. So I can create user groups. So let's just go to the edit format and we can recreate a different name for it if we'd like, and we can then set permissions. So you can see here, the user group right now has the ability to write to a dashboard, but it has no other rights whatsoever. So all of these are selections that you can pair up with user groups. Then you can add however many users to each user group you want and give them access to particular missions, particular maps, particular functionalities based on the plant, based on the applications. Now, if I go back over to just users, so you can see the various users that are in here. This particular one, it's marked distributor. It's got my name and email address associated with it. That's because if I go up to the top for help, I can immediately figure out who to go to for assistance. But if I go and edit that one, you'll see that I've got the ability to change password, email address. If it's a single dashboard user, I'd select that. That's where breaking the plant up into areas really helps. And if I wanted to know what capabilities that one has, I'd go back over to the user groups and I'd look at distributor, and I would see that it's full. It's got full capabilities, as does this service one. You notice they're all grayed out because they've got full access. So I go under the administrator, and you see again the administrator, full capabilities. Now at the distributor level, then you would also have access to that last button on each one of those. So with the different users, you also have the ability to set up simple PIN logins. So you could have a 4-digit PIN rather than them having a login password that they have to remember. Depends on your preferences at the setup at the admin level for the whole group of people. Any other questions? So if I go to the hook and I go to manual control, you see I have the ability to open and close the jaws of the hook, activate and deactivate the brake, change the height, that is the height of the hook off of the floor. And you'll use these manual settings when you're setting up particular carts to pull, but then you'll get into the menu for carts and you'll place a cart in the position where it would be ready to be picked up, and you go through the series of steps, including adding the QR code that it used to identify the cart and position itself well in relative location of the cart to grab it in this menu here. And then once you've done that, you have the ability to add picking up a cart in the mission queue, and you can specify a particular cart to pick up in a location, or you can pick up any cart in that given location. I won't go too much into the weeds on carts. It's pretty specific to the application and takes a little while to set up each of the carts so that you get them right. And it has to do with the length, width, height of the cart, the relative height of the hook when you're moving into a position to grab it, relative height of the hook when you're going to squeeze and give control of that cart, and the relative position of the fixed set of wheels on the cart to the hook itself. So if it's got the fixed set in the front of the cart or the rear, that's also a part of the setup for it. Let's just go into software versions for a second. You have the ability to upload new software. Again, that's great because like a smartphone, this thing's constantly getting smarter with new versions of the software. And you just grab a hold of a software file, you say upload, you go find the software file, and then you start the upgrade process. It's pretty quick and painless. And you can also revert back to previous versions by just grabbing a hold of one that is your past version. I recently brought this one up to 2.0.14, and so you see it came from 1.9.13. I've got the ability to revert if I'd like. Go into settings. Again, these are all the hook. Cart types. Let's go into system for a second. Go into system settings. So this is where I would jump into a variety of settings for the unit itself. Processes, things that are running on board. PLC registers. You notice that you got integers and registers 1 through 100, floats 101 to 200. Again, you can pass data to the device either through an onboard PLC that would be attached to some push buttons on the unit. So in a simple form, you could have 2 push buttons attached to a PLC on board the unit, one labeled go to work in process, the other one saying go to shipping. Touch one of the buttons, it adds a bit to one of the registers. You simply read that register inside of your mission, and when that register is true, you head to whatever location that it's significant for. In the robot setup, most of this is self-calibrating, but occasionally you may add an upper camera, so you'd add a top camera. You'd add its serial number to the queue here. I'm going to just run one more mission here, and we're going to kind of wrap up. So I'm going to use my dashboard, and I'm going to run a map 1 to map 2 transition mission. You can see it's running right now. And it's first moving to a position right here. And as soon as it moves to that position, it's going to change to a separate map. The second map is for the other end of this hall down here. And once it changes to that separate map, it's going to then take a move to a location that wasn't even on the previous map. So you can see now it's on a wholly new map system, and I can go to a location on that other map, or I could have had it automatically go to that as a part of that mission. You notice also there's a little shaded box right here. That shaded box is an area event. So as the robot is moving through that narrow hallway, I've also got it flashing its lights so that it alerts people that it's in a narrow space. It's really all I had for today. I wanted to give you a peek at the new user interface, and I'm going to take another look for questions. And I don't see any other questions. At the end of the webinar here, I'll go ahead and send you the slide deck, and feel free to contact me. My information and contact information will be on that same email, and be happy to cover any questions you have. Also be happy to come out to your facility and do an on-site demo. Let me know what you need. Thanks very much for attending today. Hope the rest of your day is spectacular.